This presentation is adapted from a paper presented at the 2014 NERA conference. It's entitled Motivational Filtering, Comparison of a Test-Specific and Global Measure of Student Effort in Low-Stakes Testing. The co-authors are Courtney Sanders, Carolyn Meeson, and John Hathcote. Low-stakes tests by definition have no meaningful consequences for the student. However, oftentimes these tests are high stakes for the institution. Student motivation is a concern because students who fail to give their best effort will have scores that do not reflect their true ability. Motivation filtering is a technique that is used to control for the source of invalidity. Prior research has shown that this technique tends to be effective. However, most of this research has focused on global measures of effort, which measure a student's overall effort after an extensive battery of assessments. Motivation theory would suggest that there would be benefits from examining test-specific effort as opposed to global effort. Test-specific effort is a student's reported effort on a single test. Also, prior research indicates that effort tends to change over time or across a battery of examinations. This implies that we may get more accurate information if we filter according to test-specific effort as opposed to global effort. Our research questions were informed by two general questions we had. The first general question was if test-specific motivation predicted student performance over and beyond global test-taking motivation. As such, we examined the zero-order correlation between test-specific and global student effort, and we examined the variance in student performance and test-taking effort that was accounted for after controlling for student ability and global test-taking effort. The second general question was if our decisions about the quality of educational programming would change if we used a test-specific method instead of a global method of motivation filtering. As such, we sought to determine to what extent both methods agreed about which students should be eliminated from our analyses. We examined how aggregate-based statistics would compare when filtered by both methods. And finally, we explored the extent to which judgments about the proportion of students who would meet faculty standards differ when filtering by the two methods. Our sample consists of 676 undergraduate students who participated in a university-wide assessment day. This assessment day was mandatory and was low stakes for the student. These students had completed between 45 and 70 credit hours. 64% were female and 36% were male. 91% were white. These students were exposed to a battery of tests in the following sequence. First, they took a cognitive exam called the Natural World 9. They then completed the test-specific student opinion scale, which was our measure of test-specific motivation. This measure pertained to their motivation on the Natural World 9. Afterwards, they completed 111 non-cognitive items, another cognitive exam, and 81 non-cognitive items before ending the battery by completing the Global Student Opinion Scale, which was our measure of global motivation. This measure pertained to their motivation on the entire battery of tests. The global and test-specific student opinion scales consisted of 15 items. There were 3 subscales, each consisting of 5 items. We used the effort subscale for our analyses. The items were scored from 1, strongly disagree, to 5, strongly agree. As such, the possible range of values was between 5 and 25. An example of a global item is, I engaged in good effort throughout these tests. An example of a test-specific item is, I engaged in good effort throughout this test. The Natural World 9 consisted of 66 cognitive items measuring scientific reasoning skills within general education. SAT Verbal, SAT Math, and a cumulative GPA were used as proxies for student ability for control purposes. I will now hand it over to Courtney to discuss results and implications.
Prior to implementing motivational filtering, there are 2 assumptions that should be met. First, student effort should be correlated with performance. Here we can see that there were moderate correlations between both test-specific at 0.47 and global effort at 0.40 with scores on the Natural World 9 test, with the correlation for test-specific effort being a bit higher. The second assumption that should be met is that student effort should not be correlated with estimates of ability. Here we can see that the correlations ranged from 0.11 to 0.12 for test-specific effort and our estimates of ability, and from 0.09 to 0.13 for global effort and estimates of ability. Although statistically significant, the percent of shared variance between effort and ability was generally less than 1%, which in our judgment failed to be of practical importance. Also, the correlation between test-specific effort and global effort was large at 0.75. This implies that the between-student differences in reported effort were generally consistent across the test battery. The magnitude of the correlation also suggests that test-specific and global effort failed to be completely redundant. This implies that there may be possible benefits of measuring test-specific effort over and above global effort. To investigate this possibility, a hierarchical linear regression was conducted in 3 steps. In step 1, GPA, SAT Math, and SAT Verbal were used as control variables. Second, global effort was added as a predictor to the previous model. And third, test-specific effort was added to the model to examine whether it accounted for variance in student performance over and above the other variables. Test-specific effort accounted for approximately an additional 4% of variance in NW9 scores after controlling for other variables. In the final model, increases in both test-specific and global effort predicted increases in student performance while holding ability constant. This supports the position that test-specific effort contributes to student performance over and above what is captured by global effort. In the following sections, we'll look at practical consequences that result from the application of motivational filtering from both measures of student effort. In terms of identifying an optimal threshold, we examined and filtered by the point at which mean SAT scores failed to change by more than 3 points from the original sample SAT mean. This is a technique that was discussed by Wise, and Bola in 2006. This value was used as the optimal level in order to prevent inadvertent deletion of students from the sample who happen to have lower ability. Differences of mean SAT scores at different levels of filtering were examined using both SAT Math and SAT Verbal as criterion. SAT Verbal scores tended to change more rapidly than mean SAT Math scores across different levels for both test-specific and global effort. This indicated that SAT Verbal should be used, at least with this sample, since the optimal threshold for SAT Math would have greater implications for confounding low ability and effort. Effort scores of 14 were identified as the optimal threshold. This retained 559 students for global effort and 592 students for test-specific effort. Both techniques had an agreement rate of 87.1% across the entire sample when filtering. This is greater than suggestions from prior research which indicate approximately 67% agreement. Mean NW9 scores after filtering using both techniques were similar: 50.89 for global and 50.94 for test-specific. This was evidenced by the extremely small effect size, Cohen's d of 0.007. Similarly, differences between mean values before and after filtering were similar across both methods from the original sample mean of 49.91. The differences between this value and the mean obtained after filtering using global effort is nearly equivalent to the differences obtained when filtering using test-specific effort. We can see that the effect sizes for both measures of effort and the original sample mean are similar. These differences fail to offer substantive decisions about quality of the educational program at the aggregate level. This is further supported by looking at the proportion of students who were judged to meet faculty standards across both techniques. Approximately 59.2 met the faculty set standard at the post-test for global effort, and 58.3% for test-specific effort. These differences may be considered trivial since they fail to result in divergent conclusions about educational quality. Overall, motivational filtering using test-specific effort does seem to contribute something over and above global effort measures. However, the results of this study indicated that this failed to translate into anything that might be of practical value to institutions. It is important to consider that measuring test-specific effort comes at a cost of requiring additional testing time for students, and it may lead to other concerns. For example, we may need to worry about student fatigue and issues that could result from repeatedly administering the same instrument multiple times during the same testing session. Taken together, the results suggest that the potential benefits of filtering according to test-specific as opposed to global measures may simply not outweigh the costs. However, this does not mean that we should completely abandon measures of test-specific effort. There are some considerations that we should keep in mind. First, self-report data was used, which assumes that students interpret the scale the same way, which may not necessarily be the case. Also, this research has not investigated motivational filtering when applied to value-added outcomes. Filtering according to changes in motivation over time, as opposed to a fixed point in time, might show very different results. Given these results and considerations, future research needs to look at these issues to see if there is additional evidence to support using measures of test-specific effort. Thank you for watching this presentation. If you have questions or would like to contact the presenters, please use the email addresses shown here.